All right, so let's talk a little bit about the software development lifecycle, and like the name suggests, right? As we develop software, right, it has certain steps, right, that the software goes through its lifespan, right, from gathering requirements, design phase, implementation, testing, deployment, maintenance, right? So there's very well defined set of steps through which a piece of software, any line of code, will go through in its lifespan. So let's take a look at some of the techniques, some of the strategies that have evolved over time, that have worked well, that haven't worked well. Where are we today? That has and some of the factors that have caused these methodologies to evolve over time. Okay, and perhaps you as you go out in the fields and start using some of these methodologies, perhaps you'll be discovering better ways, right? Better methodologies, right? And you'll be the author of some new and better way of doing things and of developing software, right? So it's a work in progress. We are a fairly young industry, and we're certainly still learning how to deliver quality software. So certainly it's not an easy task. So the most important thing to understand is that we are going into a business in the middle of the story, right? It has a long history, right, of going through various instantiations of software that might have different aspects of some legacy systems that have been going around, some software that is fairly old, some that is cutting edge, right, and everything in between, right? So it's very unlikely that you will have the chance of getting started on working on a project that is pristine, right? That you can decide what from the beginning. What actually the stack that you're going to use and the database and the data models and everything. The more commonly you will be jumping on an ongoing story, right? Like a book, and you start reading it right in the middle, right? And you try to make sense of where you have been, how we got here, and hoping to know where you're going, right? So it's a process, right? You're in the process, and the process is always moving, right? So don't be complacent and think that things are static. It's only an illusion, right? Everything is always moving, and depending on where you are in this process, you have aspects that you can change and certain things that you can't change, that you have control over, right? If you're in the team, in the software development team, you can change certain aspects of the process, right? You can change how certain things are going to be implemented, certain functionalities, how they're going to be implemented, the tools that you might want to use. You might even be allowed to choose that you need a week to implement that functionality, or 2 weeks, right? So you might control the pace in which the process moves forward. Some of the costs, and the technology and the stack that you might be using, and who you're going to be able to hire, right? And depending on the availability in the market and what HR imposes on you, right? So different folks in different teams, different audiences will have aspects that you can change, that they can change, and others that they can't. Now, working by yourself, it's fairly easy. Okay, you're not accountable to anybody, right? You can decide exactly what you want to do. Nobody's looking over your shoulder. Nobody's criticizing you. When you start working in teams, it's several orders of magnitude much more complex, right? and oftentimes it might feel constricting, right? That you are beholden to the team, right? There's needs for lots of communication, of sitting next to each other and pair programming, right? So communication oftentimes is crucial, right? And you should be open to that, right? That let's just sit together and let's bang this this afternoon, and we'll solve that together. If we don't understand something, we go off on the whiteboard and start drawing diagrams and says, "Ooh, this might be useful for posterity, right? Let's document all this class diagrams, this sequence diagrams. It will be useful for whoever comes behind us, right? And it will be easier to onboard the new folks, the new junior developers that might come after us, right? Anything that we can do to improve the efficiency of the team, it'll make our lives easier as well." Right. Also, the tooling that we're going to be using, how we're going to hand off if this code ever is going, some other team might own this later, right? Or I might move on to other better things, right? And I'm gonna have a knowledge transfer on somebody else owning this, right? So anything that we can improve that as a team, it's much harder to work, and we have to take into account those things. A lot of the influences is that you might not be working on something that is pristine, something that is legacy, that might be using really old technologies, and nevertheless you'll need to interact with them, right? Either by creating some web service that wraps that old legacy system with something that is newer, or proposing migration to other better systems for something that makes sense. And also other things is the scale, right? And oftentimes we're not aware on how the magnitude of that there's no way that any one person might fully understand the entire system. I might understand small pieces of it, right? But I have no clue on how this fits into the larger picture, right? That's why we need the help of other folks, right? And we create all these abstractions and interfaces and ways to interact, right? So that we can divide and conquer, right? And I can focus on my little piece, right? And then at some point it has to work with somebody else's piece, right? So that we divide it and be able to work on the complexity and deal with the chaos of working with multiple folks. Okay. Again, several key elements that are useful for measuring whether a process is the key aspects of a process is that the first time is even the technological solution feasible? Can we actually do this? Do we have the knowledge in-house? Will we need to hire the folks, train, or should we just use some? Can we use what's internally that we already know, depending on the risk factors that we care about? Generating all the requirements and the specifications that are going to decide and agree on what it is that we're going to be building. The choice of a particular architecture or design, the development, validation, testing, and acceptance by the business, and then once it's deployed, having to babysit it and maintain it going forward as new requirements might change or bugs are reported. Now, since the beginning of our industry, folks have been writing code, right? And different teams over time have considered different methodologies on how do we address programming and delivering value to our client. Early on, it was fairly chaotic. We would build a first version, and we would hand it off to the client to see what they would think, and then we would just iterate until we got a favorable feedback from the client. We would modify until the client was satisfied. We would operate it for a time, for months, years, and then eventually it would be retired. So this was a fairly simple model on how the life cycle of software was back then. Oftentimes there was no what was called a separation of concern. Different aspects of the software has different concerns, right? The storage of databases has its own challenges. The network creating network communication systems has its own challenges. Creating a user interface that it's useful for the users has its own challenges, and each one of them has its own skills. Right? It used to be that everybody would do everything, right? Granted, those systems were fairly simpler, right? But as systems have grown in complexity, we've identified many different skills that are specific to the different concerns of different aspects of the application. So there's certainly you can do a whole career on the client side, right? Of making it look pretty and styling it and doing all CSS and HTML and never be bothered with storage and networking and servers and any of that, right? Or you can make a whole living on just being on the server side, right? On just the databases and networking and services and doing the algorithmic part of it, right? Or somewhere in between, right? On the middle tier, or doing client side with JavaScript and whatnot. So we have become very specialized, right? Each one of them with its own concerns, right? Its own skill set. But back then, there was no separation of any of these concerns, right? There was no real formal process and no way to deal with the growing complexity of these systems. As we evolved and had bigger machines, bigger memory, bigger CPUs, and more powerful, we expanded on the possibilities of what we could build, right? And tackling ever more complex types of problems. So one of the more models of dealing with the growing complexity was what became known as the waterfall model, right? That described very, very formally what we would do at different stages of the life of a piece of software, right? We would first meet with the client and gather the requirements over a long period of time, and once we felt satisfied that we agreed that what it was that we were going to build, we would go into a design phase, right? And create all sorts of documentation of class diagrams, ERD diagrams, and sequences, and activity diagrams, and whatnot, right? And document it completely. Once we felt confident that we had it all the documentation that we needed it, we would go on to kind of like a planning phase, right? What we would do first, right? Then a development phase, right? And we would not start the next phase until the previous phase was fully completed, right? It was very, very strict on the way this progressed, right? Then we would build it, we would deploy it and maintain it, and then we would be done, right? It would be a big celebration, maybe, hopefully, or more typically what would happen is that we would in this process. The only time that we ever saw the client was very at the beginning, right? And we were communicating and gathering the requirements. We would go off for a couple of years, right, building this, and then we would come back to the client and say, "Hey, we're done. Look," and usually, hopefully, it was exactly what we were asked to do. The client would look at this and says, "I hate it." He says, "Why? It's exactly what you asked me to do." He says, "Well, yeah, I know it's exactly what I asked you to do, but now that I see it, and I touch it and I'm using it, it's awful, it's terrible. But why, right?" And what we've discovered that was missing from these types of model was user collaboration. Including the user as a partner, right, and collaborating with them throughout the entire process, right. And today it's much more common that the end users, right, or at least somebody who, a proxy of an end user, or somebody who understands the business is an active participant of the development team, right? That we do, every week or every 2 weeks, we're demoing the progress of the software, right? And the client is looking at it, and we're getting feedback immediately from the client, and that feedback just feeds into whatever we're going to build right away, right? So So any deviations or any if we're straying away from what the client would want, right? We get immediate feedback, right? We can recorrect right away every 2 weeks as opposed to every 2 years, right? So that allows us to immediately make sure that we are on track. Okay. All right. So I'm going to leave it here, and we'll come back and continue our discussion on business, on the process modeling.